So in this question, we have a graph to start with, so we'll analyze it first. We'll do our Oi Zerga. So the origin we look for here, and we see 0, 0 is right there. So let's draw a line here to keep our attention focused on that is the 0 axis, and there is the origin over there. The y-axis, we have velocity with normal units. We have time on the x-axis with normal units, and we look at the intercepts. So this here is the v0, is the velocity at time equal to 0. So we see that it's positive 8. And so that's the y-intercept is positive 8, and that is equal to v0. And our x-intercept down here is the time at which v equals 0, or it's stopped. And that happens at 4 seconds. So now we go to what we can read. We can read the axes, velocity and time. And we can see that as time progresses, the velocity decreases to 0, then increases in the opposite direction. So we see the velocity is positive here, and then the velocity is negative here. So like this is an up, and this is like a down. Maybe. We haven't read the context yet, but that's what we're looking at. The slope is delta v over delta t, which is the acceleration. And we notice the acceleration in this case is negative. And it's constant because the slope is a straight line. Everywhere on the line, the slope is the same. Now the area, v times delta t, that's meters per second times seconds. So meters is delta x, or the displacement. So a variation time of an object moving along a straight line. So this is not an up-down thing. It is movement along a straight line. So we have our positive direction here, our negative direction here. So this thing is moving positively in this direction, but it's slowing down and eventually comes to 0, a stop, and then it speeds up in the other direction. So this might be like someone running and they've got a bungee cord on them. They're running and then the bungee cord gets harder and harder. It slows them down. They come to a stop and they head backwards in the negative direction. All right, so the question is, what's the displacement? Well, displacement, we said, is the area. So we want the area between 0 and 6 seconds. So 6 seconds is over here, like so. So we want the entire area. Now, we might notice here that we have negative area, like this. So we have negative area, and all the other area is positive. Now, if we look carefully here, we're going to see this negative area is going to cancel out some area that's positive. And if we look here, this is time 4 and this is time 6. So if we go back to time 2, this delta t being time 2, and this delta t being 2 times, then this area, this positive area, will be equal and opposite to that negative area. So those two cancel each other out. So ultimately what we're looking for to get our answer is, the displacement, is simply the yellow area. Now we could have found all of this area and all of this area and added them up, and it will give us the same answer, but we kind of simplify things for us by just focusing in on the yellow area. Now that yellow area, we could view it as a trapezoid, or to simplify things a little bit, we could view it as a square and a triangle. I always find it useful to write the dimensions on it so we don't make a mistake. So 2 and 4. So it looked like a square, but it's not really. It's a rectangle. So this gives us an area of 8. And this is 2 and this is 4. So 2 times 4 is 8, and half of that is 4. So 8 plus 4 gives us 12. And that's why the answer is choice B. Now, we could look through and try to eliminate all of these other answers, but 2 meters is a very small amount of area. 2 meters is like this, 2 times 1. So that can't be it. And if we look at 20, well, let's see. This is 12 over here. This is another 4. That would be 16, and this would be a minus 4. So minus 4 plus 4. We would have to view these as all plus 4 to be able to get to 20. That's not it. And 24 is more than any possible combination of areas we could come up with.